Hello everyone. In the previous lectures, we discussed the technologies leading up to the cloud as we have it today. We mentioned about the advancements in distributed computing, grid computing, etc., and how those networking technologies contributed to the development of cloud computing as we have it today. Recall from the last lecture that cloud computing was derived from principles that were a part of distributed computing. Although a cloud appears as a centralized set of resources, the reality is that it is a distributed environment that supports resource sharing. The resource sharing ensures that organizations are able to keep up with the ever increasing demand for computing power and storage requirements. To this effect, we looked into what we mean by utility computing. Uh, and we know that utility computing is where computing resources are made available to consumers as a utility, like your everyday electricity, water, etc. So it's computing is treated as something which is built, something which is a utility. So yeah, so that's what we covered. That's what we have covered so far. Now, this week's lecture might be a very short set of slides which lays the groundwork for the advanced concepts which we will be studying later. Normally, lectures last for an hour with lots of interactivity between us and you. But because these are pre-recorded or other recorded lectures, the lack of interactivity makes them bit shorter. But you know how it works, guys. If you've got any questions, please let us know, and yeah, just drop into the live sessions, and we can answer your questions there. It's not just about listening to these slides, but it's also about the need to reflect on what you learn and how it applies to what you do with the lab task. So in this lecture, we will be looking at the fundamentals of cloud computing, as the slide says. The previous lectures only spoke about the growth of various technologies and the evolution in networked and distributed systems. But in this lecture, we will see what cloud computing means to us. But the difficulty is, depending on who the user is, their perception of cloud computing differs. It is quite difficult to provide a single definition of a cloud. For most people, the simple explanation of cloud computing is, accessing the computing resources off the shelf. Everyone who uses cloud computing resources know that it provides for an elastic, self-managed, cost and energy effective cloud computing environment. Cloud computing has transformed the way we work, and it provides added value. It has allowed organizations to consolidate their resources and reduce their IT infrastructure. Well, yeah, one of the main thing is, it's an investment, isn't it? So, do you really want to be investing all this money into IT resources when you could achieve or probably get greater processing power if you subscribe to a cloud computing environment? So these are some of the decisions that modern businesses have to make. Also remember, one of the contributors is also need to prepare for the economic downturn. I mean, we know what's been going on lately, but I mean, for the past many years, there has been a general, people have been a bit wary about the economic downturn. So businesses could be hesitant in investing so much towards their on-site resources. So all of these contributed to mass adoption of cloud computing. So like I said before, companies these days don't invest much on centralized IT resources. That's not required because they know that they have so many cloud service providers at their disposal. So what's the lecture's agenda? We look at the we'll try to at least look at the definitions. Then we look at the characteristics of cloud computing environments, and we also address why cloud computing is so versatile. We will also look into the attributes of cloud-based environments. So what are the properties of cloud-based environments? So, what is cloud computing? You might think that we have addressed the question of what is cloud computing, but have we really? I mean, the situation with cloud computing is like the illustration you see on the slide. It's like a bunch of blindfolded men trying to figure out the parts of an elephant. So this goes back to what I said earlier. The perception depends on who is using it. It means different things for different people. Also, people who use cloud computing, people use cloud computing at varying levels. So it is difficult to precisely define what cloud computing is. Another complexity is that there are so many variants of cloud computing. There are, as you probably know, there are public clouds, private clouds, hybrid clouds, community clouds, cloud sourcing, cloud bursting, etc., etc. If you ask a non-technical person, they would use the word cloud computing as a metaphor for the internet. There are so many features in the cloud that pretty much every combination of defining a cloud sounds correct, and that's a kind of the complexity. I don't think there's one very accurate definition of a cloud. Yeah, pretty much everything sounds acceptable. Yeah, so there are some interesting quotes there. There is Larry Ellison saying that cloud computing has been redefined as a cocktail of everything we do already, a mix of best practices in computing, if you like. Then there are others who say that it's a marketing gimmick, it's a marketing hype campaign. There is a common view that cloud computing is a trap uh, that ropes people into proprietary technologies. There's some truth to that, some element of truth. Um, so that debate will always go on. So yeah, probably there is some sense to those quotes you see on your screen. But in general, cloud computing seems like a bundled package of computing resources and computing power. We always wanted computing power, and we could always have computing power if we invested in resources. What is different is that the model in which it's delivered. So it's that model which is called as cloud computing. So we could always have the power if we invested in resources. So in the past, businesses used to buy centralized servers, networking equipment, routers, switches, everything they needed. If they needed more power, they used to add more servers, they more powerful servers. So this has been happening for many decades. So the computing power, in terms of computing power, people could always have it. Um, but now the world's changed. So you can get you can get the computing power by subscribing to a cloud service provider. So it's a way we do things. It's that model which is different now. But let us not forget that there are many among the IT community who are very skeptical about using cloud as a one-stop solution to all computing requirements. I think there might be quite a few. There might be quite a few of us as well who think, oh, maybe that's not the cloud is not. It's not all the picture is not all rosy. There are concerns, obviously. There will always be concerns about data confidentiality, location of data, compliance, and cloud security. So as I told you before, the debate will go on forever and ever and ever, and that debate is, the debates are bound to be there because with any technology there will be always the pros and the cons. So yeah. Now then, normally we don't recommend using Wikipedia as a scholarly source of information. Now we don't do that, especially with higher levels, level 6 and level 7. We don't uh, tell students to look at Wikipedia. But having said that, we are looking for simplicity here. We're looking for we're looking for a simplistic definition of cloud computing, and Wikipedia has some possible straightforward definitions which are easy to understand and which reiterate what you have said before. The first bullet point talks about on-demand services which reflect upon the utility-based model. The second definition talks about the dynamic scalability of virtualized resources. It also mentions about providing services over the internet. And then we also have references to providing applications using software as a service. We briefly touched upon software service in the very first lecture. And we will of course cover more of that later on. Let us see what the NIST says about cloud computing. NIST is the National Institute of Standards and Technology. Well, the NIST gives a slightly more of a technical definition of a cloud, which mentions on-demand network access to a shared pool of network resources, like servers and storage and applications. It can be rapidly provisioned and released with very minimal effort. You can pretty much spontaneously subscribe to resources, and it also promotes availability, and it's composed of 5 essential characteristics, 3 service models and 4 deployment models. If you want to go into more detailed definitions, actually, if you go a bit more deeper, you'll find definitions that talk about network-enabled services with guaranteed QoS or quality of service. Right, then it might seem that there is a lot to absorb on this slide, but most of what is there kind of summarizes some of the stuff we have discussed already. We will discuss some of these in more detail in the following slides. The only thing on there which we did not discuss is discuss in detail rather is the SOA or the service oriented architectures. So the SOA is a software design paradigm for, I'll try to make it simple. The SOA is a software design paradigm for cloud where applications are used to provide users access to software components over a network. Now that might sound very complicated. In simple terms, what it means is that there is an underlying platform, a set of software, if you like, with the APIs and whatnot. So users can use these software components without knowing what really lies behind the scenes. So they could access these software components over a network. So from their front end, from their interface, users or developers could access software components. These are called service-oriented architectures. So what they can do is they can pass messages across software components over the cloud. So this allows for users to use the functionality of a software without knowing the underlying complexity or how they have been implemented. It kind of shields the users from all that complexity. In SOA or software service-oriented architectures, software components are accessed over a network. Now, if you think about what we said in the past couple of weeks, you can see how SOA, service-oriented architectures, fits perfectly with cloud computing, as the cloud could host a set of software, obviously, and they can be accessed by developers over the network. It also fits perfectly with the concept of distributed networks, which we saw in the previous lectures. Because the thing we got to understand is these software components can be distributed across multiple entities. So in a way, it kind of fits perfectly with distributed networking environment. At the same time, messages can be passed from one software component to another over the network. So that's what that's kind of actually. I mean, I tried not to complicate things. That's the simplest way of describing SOA. But you will you will look at SOA a bit more in detail, especially when you're doing an assessment. You might want to consider how you use the SOA architecture towards your own assessment. It's entirely up to you. Then on the slide you also notice this other thing called as SLA, which is service level agreements. So service level agreements are extremely important in establishing the minimum service available to available for various services, various functionalities and applications within a cloud. The thing is, the cloud environment needs to control, rather the hypervisor needs to control various elements within the cloud to make sure that it strictly follows the service level agreements. So the thing is, it's got to be done in real time. So the SLA is like, in simple terms, it's like a rule book, if you like. It's like a minimum accepted level of service for users and for applications. So this got to be dealt with in real time. SLA also determines the management activities of the cloud platform and also the level of control over policy and performance criteria. Now we will, if you go a bit more deeper, they call these things as orchestration. So when a hypervisor deals with the different aspects of SLA and aspects of management, it's called as orchestration, and these needs to be done in accordance to the what is mentioned in the service level agreements. The rest of the bullet points you see on the slides have been discussed briefly in the previous lectures, and we will cover them in more detail in future lectures. So let's not again spin the wheel. We've already explained what these things are. Instead of so what we'll do is in the future lectures we will go a lot more detail into these. But for the time being, you need to know the properties, what the properties are, what the service models are, what the deployment models are, etc., etc. So all of that has been discussed already. But for now, we'll study the characteristics of cloud computing in some detail. Recall that the characteristic of cloud computing are on-demand service, broad network access, resource pooling, rapid elasticity, and measured service. The next few slides will describe these characteristics in slightly more detail. So these are pretty straightforward to understand. The on-demand self-service characteristic, we can see that the first bullet point, the on-demand self-service, what does that mean? It describes the ability for users to unilaterally provision computing capabilities such as server time. So if you want to subscribe to a server for say for about half an hour, 45 minutes, 1 hour, or as long as you need it, you just subscribe to those services. So within the parameters of service level agreements, the SLAs, which we discussed in the previous slide or the slide before that. So within the parameters of the service level agreements, a user can pull computing services off the shelf and use them for their computational needs. Obviously, when it's not needed, they can release them. So they subscribe, they release the resources. So the cloud service provider only needs to provision for the availability of resources through their data centers. But once subscribed, the users can consume it as and when needed. So we use the word consume there. So that's what it is. So just as you consume utility, you consume the resources. You use it. When you don't need it, you just release it back. So it's as simple as that. So next one on the list is broad network access. it is, if you look at some of the literature out there, some of the term books, they also refer to this as ubiquitous network access. Yeah, in simple words, it means that a user must be able to connect to the cloud resources from wherever they are and with whatever they've got really. The idea is that users should be able to use standard platforms and simple connectivity without really having to install dedicated network resource or cabling. So what standard means is, I mean, if you've got a basic internet line, if you, yeah, that should be sufficient to access some of the cloud resources. So it's not complex from the user side of view. So he needs a laptop and connection to the internet, and he can access to the immense computing power provided by the cloud. So yeah, the expectation is that users don't need any dedicated hardware for access. All you need is a heterogeneous thin or a thick client platform, and there you have it. So from the cloud's perspective, the cloud management platform should provide a uniform view of the virtualized resources. I think we touched upon this a couple of weeks ago. So it's all very complicated from the back end side of things. But the user should see a uniform view. So he shouldn't be exposed to this complexity. So he should be able to see a uniform view of the virtualized resources. In a cloud environment, the resources are pooled, which means that there is a common collection of resources that are shared. And that's the whole point, isn't it? I mean, reusing of resources, sharing of resources, pooling of resources, it's all a part of the cloud. However, so think about this, even if the resources are pooled, the resources are shared, each user has their own protective boundary when using the resources. Pooling of resources is one of the reasons why cloud computing model is cheaper to use, as it can be dynamically assigned and reassigned without the need for user himself to invest in the resource. The trend we see these days is that big hardware appliances, the big hardware appliances are being replaced with small virtual appliances, and that makes perfect sense. So we don't invest in big data centers anymore, not locally we don't. So if I need a data center, I would rather subscribe to a cloud data center rather than building it myself from scratch on premises. So, but that's what, if you look in traditional networks, that's what you see. So the traditional network design relies on placing resources like network appliances at strategic points on the network. The problem with that traditional approach is that all network traffic flows through what we call as an aggregation point, or rather a set of aggregation points. So these points need a lot of computing power, and hence they're probably the most expensive entity. So if you look at an organization, if they decide to deploy on-site computing resources, there'll be so many points within that IT infrastructure which are extremely expensive, right? Because they need all this processing power to process network traffic, and you never know, few years down the line there might be a need to add more servers. So it's like a never-ending story. So this thing about deployment and upgrading it's a constant expenditure. So the way to alleviate that issue is to subscribe to a cloud-based environment. So yeah, so what we're saying is the cloud has changed all of that. So the cloud has changed the way we see computing, and it has saved so much money. So the ability to use virtualized networks has pretty much ensured that users can get unlimited resources. Although resources are not unlimited to a user, when he subscribes to the resources, it appears as if it's unlimited. But in reality, even with the cloud computing environment, there is a limitation to the resources, because if you think about it, virtual resources are uh, are created from physical resources. So how much can you spawn from these physical resources? So you got to understand that. So the number of virtual resources is dependent upon the actual physical resources. But let's not think too much about it for the time being. Um, but yes, if you wanted to look more into this, into network functions and virtualization, there is a very interesting concept called as NFV, that is Network Function Virtualization, which describes how all the network functions um, can be virtualized. There is a lot to read up with NFV. So if you're interested, just look at some literature on NFV. NFV is also the foundation of SDNs, which is software-defined networks, which of course we won't cover in this module, because if I start talking about software-defined networks, it's going to probably take another 12 or 13 weeks. So man, just to cover it's just the tip of the iceberg. So yeah. So, but if you wanted to learn more about software-defined networking or NFV, yeah, that is it's a quite a current area. So, if you are interested, if you want to know a bit more about how networking works, the network virtualization works on a cloud platform, then please do more research on NFV and SDNs. Now, the second bullet point, there also mentions about location independence. So then we discussed this in the context of distributed networks, what location independence means. It is the same concept where the end user has no knowledge of the exact location of the provided resources. But users do sometimes have some choice of general geographical location, if that makes sense. For example, the users might be able to choose which CDN or content delivery network should be used for better speeds and efficiency. So there is some amount of choice there, but the more stringent orchestration and management is done by the cloud platform itself. So there are numerous examples we can provide for this. So when we talk about resource provisioning, one really good, the things which we can provision are things like processors, memory, and network bandwidth. It's a very interesting concept. Now, for example, if you're a gamer, if you're on the Xbox or your Xbox, you may be aware that you can now play Xbox games via the cloud without actually having to own an Xbox. So if you've got a computer, you subscribe to the Xbox cloud service, and the backend in the cloud provides the computational power for your games rather than your PC. So it's a very interesting concept, as I said. So you can pretty much get any resource. Do you want the speed? Do you want the bandwidth? Do you want the memory? Do you want CPU? Do you want storage? What is it you need? You can have all of it from the cloud. So in the last slide, we had discussed the traditional approach to on-premises. When I say on-premises, on-site computing, for example, provisioning for in-house networking resources. Now then, there are two very obvious problems with this. It results in loss of revenue and loss of users. The demand is only going to increase. Let's not forget that the demand is only going to increase. So you can think that whatever you deploy today on your premises is going to be sufficient for all your computing power. But what if you decide to increase your operations? Obviously, it's going to require more computational power. So the demand for computational power and resources is only going to increase. It's not going to go down. The business can expand. When business expands, obviously your IT requirements increase. So there will always be a point where a company might underestimate their system utilization, which is quite a dangerous situation to be. So when you underestimate your IT resources, it's going to have a very detrimental effect on your business. So what do we mean by underestimating utilization? It means that there is the demand for computing power is more than what your IT resources can now handle, right? So you didn't expect this. So whatever you deployed might have been true about 5 years ago or 10 years ago, but now your business does so many other now data crunching that the on-site resources are not sufficient. So that's what underestimation means. So when you provision less resources, thinking that it's adequate, you're going to get caught out, and many organizations have been caught out. So the question is, where do you draw the line? Do you draw a line somewhere and say enough is enough? Or do you look for a more cheaper and efficient way to provision for your computing resources? But let's not forget about the other side of the problem as well. There are two sides to the problem. So the other side of the problem is overestimation. So we spoke about underestimation. Now we look at the overestimation of resources. A company might want to be safe. So like obviously, so this IT manager thinks that fine, let's future proof our business. Let's buy a lot of resources. Let's buy a lot of servers and deploy it on site. So a company might want to be safe with their ability to cater to high utilization. So what they might do is they might be reckless. They might be reckless and decide to splash out very generously on IT resources to an extent that it gets to a point where the actual usage does not warrant so much investment in resources. So yes, you have splashed out all this money on resources, but you're hardly using it. So that's another risk, isn't it? So you spend all this money and there is no return on investment. So what you then end up is with a significant chunk of your resources remain unused, or they just collect dust. So you can see that it leads to a lot of monetary waste. So what we can conclude from both these cases, so the two cases being underutilization and overutilization, so what we can conclude from that is the resources should be just adequate and proportional. It should be proportional to your utilization. If you go for an on-premises or other on-site deployment, you will never ever achieve that. You will never. It's like it's just chasing something, right? You either try to keep up with the capacity or you try to keep up with utilization, right? Or you try to optimize your resources. There's no solution to that. So that's a problem with on-site deployments. So the bottom line is like I said before. So the resources you have should be proportional and adequate to your utilization. So how do you manage it then? So how do you get the kind of this balance? How do you get this balance? So how do you prevent your overutilization and underutilization, and at the same time, how do you save a lot of money? You probably guessed it that cloud computing allows for dynamic resources provisioning. What that means is that you can subscribe to more resources as and when you need it and adapt to seasonal variations. So maybe you are in the your business is has got its peaks, peak activity and then low activity at some point. So instead of fixing yourself to a set of resources, you can get whatever you need whenever you want it. So that's what I meant by proportional, right? So depending on your utilization, it can be the resources can be proportional. So sometimes there'll be a burst of demand. A burst is a sudden and sometimes often unexpected demand for computing power. So when you use a cloud platform, you can procure and release resources based on ever-changing needs. And at the same time, you can also be certain that you are not buying more than needed or less than needed. So you just got the right amount of resources. That makes sense. So you're not buying things unnecessarily. At the same time, you are not not buying less. You are just buying the right amount using a cloud platform. So that's the advantage of dynamic resource provisioning, which is only possible in a cloud-based environment. So dynamic resource provisioning and management, well, it could include a lot of tasks, including creating virtual machines from scratch or from templates, which are done already, starting and suspending or migrating virtual machines, using snapshots, taking backups, and restoring VMs. So all of that is a part of the resource provisioning and management activities. Once a virtualized resource is provisioned, the task of controlling and managing the resource is done by the hypervisor. You guys might have heard of the hypervisor. The hypervisor, for the lack of a better term, is like the backbone of the cloud environment. So it's the core. It's central to the cloud environment. It's the one which has got all the intelligence needed to do the housekeeping tasks, if you like, to manage the virtual machines and to migrate the virtual machines, etc., etc. So it handles the input output as well of virtual machines. It handles the control, and it manages the operating the interaction between the virtual machines and the guest operating systems. So all of that is done at the core of the cloud environment. Next, we look at rapid elasticity. This somewhat overlaps with the resource management discussion we had in the previous slide, and then yeah, I think we have kind of gone around in circles here, so that's quite a bit of overlap. So where this is where the users get the view that the resources are unlimited. Cloud computing greatly reduces the runaway expenditure from what we call server proliferation. It offers a solution by consolidating small and medium sized servers into much smaller number of more powerful servers. Does that make sense? So what I said was it consolidates small and medium sized servers into much smaller number of more powerful servers. So yeah, so it's a consolidation. So if a company wanted to scale their computing requirements, they could choose to subscribe to cloud resources and build architectures which are more aligned with agile business requirements. And it's not just that. Cloud architecture provides for faster application spin-up. So we use the word spin-up. So what spin-up means is that it's already there in the cloud. You just use it quickly, rapidly, and you provision it as and when needed. And there are different ways of doing this. So we have, you guys might have heard of SysOps, which is systems and operations, SysOps, and there's also DevOps, development operations. So these are again very specific fields within cloud computing, and people can specialize in DevOps. So with DevOps and SysOps, we can not only provision capabilities, but we can also configure them with very little effort. And also we can automate a lot of tasks in an instant using the APIs. And we spoke about SOAs before, so service-oriented architectures. So similar to that is you got the APIs being exposed by the cloud environment for developers to use. So you can use the APIs and control various resources, or you can spin up computational power. So if you think about it, for let's say we want an example of what the spin up means. How do we spin up computing resources? So let's think about a scientific firm, a huge scientific firm, and they've got a huge, massive data set, and they need to perform a very computationally intensive task. So what do they do? What can they do? They've got a very complex data set, but they don't have enough computing resources on site. So what they can do is they can use elastically provisioned capabilities. So they can use APIs, or they could just spin up some computational power, get some resources, do the number crunching, process the data set, and then when they don't need it, they can just release it. Simple as that. Yeah. So finally, pretty much every resource used on the cloud can be metered. This is pretty straightforward. Everything you use on the cloud, everything. So be it hard drive space or processing, sorry, memory or bandwidth, whatever it is, or the device, everything can be metered. It all depends on what is used and how much is being used. Everything can be measured, bandwidth, storage, etc., etc. Everything. So that is an end user, a user can find out exactly what they have used and can monitor it, manage it. It provides for a great deal of transparency, right? And this also helps businesses evaluate their computational efficiency using the cloud. Because it's a metered pay-as-you-go service, you only pay for what you use. It's simple. I mean, just as you pay for your electricity bill, you don't pay extra. You only pay for what you use, and you get an itemized billing for that. Well, when I say itemized, I mean it's not like a telephone bill, but you only pay for what you use, right? So yeah, so whatever resources you use, it's metered to the penny, and you pay for it. So then, that covers this set of lecture slides. We hope that you guys are doing extra reading outside of these sessions. So far, we have only covered the basics, but we will soon be venturing into technical areas, very, very technical areas, like the architecture of a cloud platform and detailed coverage of cloud paradigms. All right. So, yeah, thanks, guys.